Hi everyone, in this video we're going to talk about section 2.5a, which is about graphs of sine and cosine. So we've always thought of sine and cosine just as ratios of some sort of triangles. Now we're going to extend that out into talking about sine and cosine as functions, where we have inputs and we get outputs, okay? These graphs are called sinusoids, so just whenever we refer to that, we're talking about sine and cosine graphs. And they do have a kind of a distinctive shape. So first, we're going to kind of derive, quote-unquote derive, what the parent function graph looks like. So first we're going to do sine of x, okay? So we're going to use our unit circle and we're going to fill in the information below regarding to sine of x. So our x values here are going to refer to radians, and then our y values are going to refer to the output of sine. So basically our inputs are going to be our reference angle and our outputs are going to be the sine ratio. So think like opposite over hypotenuse, okay? Okay, so first we have 0 radians. So use your unit circle if you need to. But sometimes for these, since we're just talking sine and cosine, I like to draw my own little here. So 0 is right here. Okay, I'm thinking sine. Sine is that y value of that coordinate point, so that's going to be 0. Okay, pi over 4 is right here. So what's sine of pi over 4? Well, it's the square root of 2 over 2. Okay, pi over 2 is up here. So what's the y value of that point? Well, that's 1. Okay. Coming over here, now we're kind of reflecting over that y-axis. We're still at square root of 2 over 2 for 3 pi over 4. For pi, we're here. So what's that y-coordinate? It's 0. 5 pi over 4 is right here. So now we've dipped below the x-axis since sine is talking about y values. That's going to be negative square root of 2 over 2. Here's 3 pi over 2. That y value is negative 1. 7 pi over 4 is here. Again, that's going to be square root of 2 over 2. And then going back to 2 pi, we're back at 0. Okay, so here are our values. We're going to go ahead and we're going to plot these on our coordinate plane. Now, here, normally when we've looked at this, we've always thought like each unit on the x and y coordinate is 1. Here we need to kind of label our axes. So this is radians. This is y equals sine of x. Okay, let's go by pi over 4's. Well, let's just start kind of by pi over 2. So like if right here is 2 pi, half of that is going to be here. That'll be pi. Half of pi will be pi over 2, which then means that in between there's our pi over 4's. So I'm just labeling my axes so I know my scale and what I'm going by. And then just taking a brief look at my output values, it looks like max and min is going to be 1 and negative 1. So I don't know, let's make this 1. Let's make this negative 1. And here's 0. Okay, let's plot our points. So, and I'll switch colors. We have a point 0, 0, right there. Okay. I'm going to skip over square root of 2 over 2 for right now. Okay, let's plot the ones that are easy to do. So at pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, we're at negative 1. And then at 2 pi, we're back at 0. Okay, so I can kind of see that it's going to make like that type of shape, okay? Square root of 2 over 2, if you do grab out your calculator and type that in, it's going to be approximately 0.707-ish, okay? So that means it's going to be like a little bit in between that halfway point and 1. So, I don't know, right here. All right. All right, let's connect our points. So there we go. Okay, so there's our graph. So one thing I just want to point to your attention is which points were the easy ones to graph, like without even having to use a calculator or anything like that. Which ones could we graph really easily? Well, they're going to be like these nice values, the ones that give us like 0, negative 1, positive 1, things like that. So keep that in mind. That'll be helpful. Okay, so here's our sine graph. Down below, we have the same thing, but now we're going to derive the parent function for cosine of x. So I'm going to have you go ahead, pause the video. I want you to fill out the table, and then I want you to try and graph it here, okay? And then when you're ready, unpause the video, and we'll check our answers. All right, welcome back. Let's go over and check our answers. So for our table, for x equals 0, we should have gotten 1 out. Pi over 4 is going to be square root of 2 over 2. Pi over 2 is 0. 3 pi over 4 is negative square root of 2 over 2. Pi is negative 1. 5 pi over 4 is negative square root of 2 over 2. 3 pi over 2 is 0, 7 pi over 4 is square root of 2 over 2, and 2 pi is 1. So then when I go to plot all of my points on the graph, we should get something like this, okay? So these are our parent function graphs of sine and cosine. Now, I will say that we only have really a part of it, okay? Because we only used a limited set of inputs. So, like, you have to think also, like, we could have inputted, I don't know, 4 pi, right? That could have been a point on our graph. We just would have gone and extended out here. So, like, where would 4 pi have been here? Well, I know that if I'm looking at my unit circle, okay, if here is 0 and it's also 2 pi, well, 4 pi is just going all the way around again. So I know that 4 pi would have also ended up at 1. So when we're looking at these graphs, for sine and cosine, they're what we call periodic. So it means that they're going to repeat the same shape over and over and over again. Okay, so let's just focus here. So like, this is our cosine graph, okay? We only graphed like this portion from 0, I'm trying to zoom in. We only graphed like this portion right here, right? But I know that I could keep going because I can keep going around and around and around my unit circle. So my graph of cosine looks a lot like this, okay? My graph of sine now, here's sine. Same thing. We only graphed like this portion right here. But we can keep graphing because you can keep going around your unit circle. So one thing that I want to bring to your attention right here is if you try to type these into your calculator and you don't get something that graphs or looks like this, reason being, I'm trying to remember how to do this on here, is you're probably in degrees, okay? So your graph might look something, I don't even know if it's going to look like this. It's not going to look very pretty though. It's not going to have that wave shape. Just know if you're not getting that, switch your calculator mode. Okay. And I'm going to write here that these are periodic. Okay, so basically what we've graphed right now is we've graphed one period of this graph. So meaning that we have one full rotation of that shape, but we can keep going and get more iterations of it. Okay, flip over your page. Let's talk about some characteristics of these. So here's the deal. In Unit 1, we learned about the different transformations. The vertical stretch and shrink, the vertical reflection, the vertical stretch, you know, everything like that. Same thing applies for sinusoids, however, we now call them different names, okay? So we just need to kind of figure out what our new names are. So first up, we have amplitude. The amplitude is the vertical distance from the midline to the max or the min, okay? So let me go ahead and draw a picture. So here, say is my graph, and let's say I'm looking at my sine graph, okay? So the amplitude is this distance from here. So it's going from that midline or that middle portion between like our waves to either the max or to the min. And this is called our vertical stretch. So like before, where did we see our vertical stretch? Well, our vertical stretch was that A value that was in front. So for instance, let's say that here my max is 4, my min is -4. I might see 4 sine of x, where 4 is my amplitude, okay? So new name for that vertical stretch. The other way to find your amplitude when looking at a graph is to find the distance between the max and the min values and then just divide it by 2. Okay, so here the distance 4 to -4 is 8. 8 divided by 2 is 4. Okay, one thing I will mention here is that normally on like just a normal parent function, think about what our amplitude would be. Like if we're just talking about like sine of x or cosine of x. Well, what's really that number that's out in front? Really, right, it's 1. So normally our amplitude is 1. Keep in mind also here that when we're talking about amplitude, we're talking about distance, and distance is always a positive number, okay? So if you see a negative is going to mean a reflection. Right, and that's going to be a reflection over the x-axis. All right. Next up is period, okay? And so period kind of refers to that periodic shape that I was talking about where we get the same iteration of the graph over and over again. We have those waves. A period is how often the graph repeats itself. So like before on the previous page, we had one period. So that was just one of the shape, and if we kept going, we would have repeated that shape. Our period's also called like, or before we've always thought about our period as like that horizontal stretch or compression, okay? So let's go ahead and draw ourselves a picture. We'll talk about it. So again, I might use the sine graph. Okay, so Okay, so here I have a couple waves of my sine graph. So like for instance, my sine graph, here is one period. Here's another period of my sine graph, and black is fine. Here's another period of my sine graph. So here I have 3 periods drawn, okay? Normally, just on a normal parent function graph, our period is going to be 2 pi. Okay. But if we have that horizontal stretch or compression, that's going to change what our period is. So like for instance, let's say that this value here, let me get another color. Okay, let's say that this value here is 2 pi over 3. Okay, that means that the period, it took 2 pi over 3 radians to graph the full period. Okay, so another 2 pi over 3 would get us to this point, and another 2 pi over 3 would have gotten us to this point. So if we want to calculate our period, there's a couple of ways that we can do it. First, well, we'll get there when we get there, okay? We'll see that on the next page. I'm just going to say right now that our period for this graph would be 2 pi over 3. So just know here that if this is 2 pi over 3, well, okay, adding another 2 pi over 3 here would have been 4 pi over 3, and then adding one more period would give us 6 pi over 3. Well, that's that 2 pi. So in this case, we were able to get 3 of these iterations in that normal period, okay? But now our period, since we squished it together, is going to be 2 pi over 3. Okay, phase shift is just our name for left or right movement, or we talked about that before as a horizontal shift, okay? So, draw ourselves a graph, okay? A normal sine graph would start at 0 and look like this, okay? And it's going to keep going. So here's like our normal iteration of that first period. However, if we shift it, it might look a little bit different, okay? So that's going to be our left or right movement. Sometimes, I just want to get your mind thinking about this right now. Sometimes it might still look like that normal parent graph, but it has to do with how much we've shifted it over. So like, let's say that original iteration actually ended up like right here. Well, how much would we have shifted it by? Well, if the normal, and let's just say that we have a normal period, everything like that, okay? If this movement over here was 2 pi to get us to the initial movement, then I might have something like sine of x minus 2 pi. Okay, where this movement here, or this number here, is going to be your left or right movement. Now, just keep in mind that we do need to make sure that we have a coefficient of 1. And we've seen that before. But it's back, so just keep that in mind, okay? Okay, last one's our vertical shift. Before we called that vertical shift. So yay, one word is the same, okay? That's our up or down movement. And we will talk about, like, when looking at a graph, how to determine that. But usually we're trying to look for where that midline is. So that midline kind of helps us figure out where we've shifted to, okay? Sweet. Okay, let's flip over our page again, and we're going to look at a couple examples. So here, we're going to find the amplitude of the functions. We're going to use the language of transformations to describe how the graph of the function is related. Okay, so we're going to do this without our calculator, okay? So we know that amplitude is that, that vertical stretch or shrink. That's going to be the number that's in front, okay? So in this case, for example, A, our amplitude, is going to be 2. Okay? On example B, don't be fooled. Our amplitude is not negative 0.3, okay? Our amplitude is positive 0.3. And I want you to think about why. Do you think about why? Yeah, it's because that negative that we have is that reflection over the x-axis, okay? So remember, from that number that's out in front, we can get really two things. We get that amplitude, but we also get some sort of reflection. So we don't want to say that our amplitude is negative, because amplitude is always talking about distance, and distance does need to be positive. Okay, concept 2, we're finding the period of the functions, and we're using the language of transformations to describe how that graph of the function is related to the graph of cosine of x. Okay, so to do this, we first kind of need to think about what our horizontal stretches, shrinks, or compressions are, okay? So I know that that number, or the number we're looking for, comes from that coefficient on x within our function, okay? So in this case, I see that I have a 3 that's here, so I know in my mind that that's going to be a horizontal shrink or compression. Right? Because whatever happens inside the parentheses, it's the opposite of what we think is happening. So we horizontally compress by 1/3. So what that means, and I'm actually going to go back one page, the graph that I had drawn here. Okay, I'm looking at that period. That means that within our normal 2 pi period, we're actually going to get like 1/3 of the way to finish like our entire graph. So for instance here, our normal period went to 2 pi, and that's where we were here. But we went 3 of those 2 pi, so we were able to finish our period in 1/3 of the time. That's what that that's what that horizontal compression means. So here, our horizontal compression, and there's a couple different ways that we can do this, okay? Our horizontal compression, or I guess our new period, sorry, is gonna come from taking our normal period, which is 2 pi, and multiplying by what that compression value is. So in this case, 2 pi times 1/3 is 2 pi over 3. Okay, so in my mind, what I know is happening is I'm able to get done with my first, iteration or my first period in 1/3 of the time a normal graph would have been. So it's like, it's really shrunk in there. Okay, and so then in example B, okay, again, that coefficient that is on X is 4/5, but I know that I need to take the reciprocal of that. So in this case, we're going to have a horizontal stretch of 5/4. So if I want to find my new period, I'm going to take 2 pi and I'm going to multiply by what my horizontal stretch was. Okay, so in that case, that's 10 pi over 4, or reducing that down, that should be 5 pi over 2. So how I'm thinking about this here is that we are actually taking longer and stretching out what that sine value is. So like our normal period was 2 pi, but it's going to take us like 1/4 more of the time to get us there. So our new period is 5 pi over 2. That's where I'm expecting to end my that period. Okay, so a couple different ways that we can do it. I personally like to think about it as like how much time it takes. So ways to find period. Okay, so the way that I like to think about it is I like to take that horizontal stretch or compression and multiply by 2 pi. Oops, times 2 pi. Okay. I feel like that's pretty familiar with what we've done before. We're just now having to multiply by something, okay? The second way is to take 2 pi, and then we're going to divide by our b value. So remember, a long time ago, I'm going to scroll up really fast. Okay, when we're talking about the parent functions, or I guess the transformations, we had this like b value. That's the number that's in front of our value of x within our parentheses. That's kind of like our b. Okay, so I'm talking about that number that's in front of there. Okay, either way that we do it, we're actually going to get the same thing. So if I had done the same thing for example A, I would have taken 2 pi and divided by the number in front of x. Well, that's 3. And that does give me 2 pi over 3, like we got over here. In example B, if I had done that, I would have had 2 pi over 4 pi, or well, 4 over 5. Well, okay, if I go ahead and multiply by the reciprocal, I'm going to have 2 pi over 5/4, and hey, that got me exactly where I got to right here. So either way that you do it, no big deal, just keep that straight in your mind. Okay, pick a way that works for you and go for it. Okay, I'm going to take a brief pause here. My dog is needing some food, but then we're going to pick back up. I'm going to have one more video.